Okay, good day guys. Welcome to Calcumind once again. And we're looking at integrating factor method. This is it's a shortcut method we are going to be using to be solving this, whereby this is the shortcut method. Let's keep that in mind. Y is equal to 1 over I of x, all in bracket, integral of I of x, Q of x, dx. So this won't seem intuitive at first, but if we walk through the process, you'll get it. So firstly, the integrating factor method is whereby we have an integrating factor problem is whereby we have a problem of x present on the right hand side. So anytime you have a problem of x at the right hand side, you should have the idea that is the integrating factor method that we are going to be working with. So firstly, how you solve this kind of equation is firstly you will compare it to the reference equation that I'm going to write out. So this is the reference equation: dy over dx plus p x y is equal to qx. So once you compare it to the standard equation, which is this, you will get out the value of px and qx, whereby px is a coefficient of y and qx is the value in the right hand side. So now from these two equations, let's identify the value of px and qx. So this 2 is the value of px and 2e raised to the power 2x is the value of qx. So in this equation, we're also going to work out the value of px and also going to work out the value of qx. So firstly, we are going to be attempting this first equation. So now, let's write out our value of px. Px is equal to 2 and qx is this. So this qx is equal to 2e raised to the power 2x. So in order to make use of this formula, we have to find the integrating factor. So the integrating factor is being represented as IF. Some textbooks call it I of x. So let's write that out. So the simple formula is equal to E integral of P of x dx. So where you see P of x, you're going to put it here and work out the integrating factor problem. So I of x, or let's call it I of x, is E integral of 2 dx. If you integrate a constant 2, it's going to be present as 2x. So if you integrate k, it's going to be integral of kx. So now we are going to be working with that idea. It's going to be E integral of, okay, we are integrating right now. So this 2x. So that is our I of x. So now we are going to be plugging it into this formula. So let's write it out. This is the formula. Y is equals to 1 over x, all brackets, integral of I of x, q of x, dx. So this is more of a shortcut formula that people use to scale or walk through integrating formula problem. So now let's impute all our parameters. So this y is equal to 1. I of x is what? E 2x. Then the integrating factor I of x also is E 2x. Then q of x is what? So you have written that out. This 2e 2x, then dx. So now we are going to further simplify this in order to take any constant outside the integral sign. For example, this 2 is not supposed to be here. We are going to take it out and further simplify these parameters. So let's write it out. Y, this 2, we are going to take it out. It's now going to be 2 multiplied by the 1 over e raised to the power 2 of x. So this will be 2 e raised to the power 2x. Then the integral sign, e 2 of x dot e 2 of x dx. So now using the laws of indices, whereby e2 of x dot 2 of x is equal to e2x plus 2x, which is equal to e4 of x. So this simple simplification aids us to further break this down. So this y is equal to 2 over e2 of x. e4x x. So now we are going to be working throughout this problem. So if you integrate e4 of x, we are going to be using integration by substitution. Let me show you the breakdown of how to work out this. So if you have e raised to the power 4x, you can decide to call this, the x. You can call this, let 4x equal to u. So let's say let 4x equal to u. So this is going to be integral of u equals to integral of e raised to the power u dx. So now if we differentiate this and this with respect to s, we'll have 4 is equal to du over dx. So now we'll make the x the subject of the formula. I know it's much more complex. It will be dx is equal to du over 4. So now, if you impute du here, anywhere we see the x, we'll put du over 4. It's going to be integral of eu du over 4. So just simply taking this 1 over 4 outside the bracket is going to be 1 over 4 eu du. And if you differentiate an exponent raised to power x or an exponent raised to power u, it's going to be giving us the same exponent raised to that power. So that is the idea now we are working with. If we differentiate this 4x, instead of going through this long formula, or if you want to save time, you can just integrate 4x and divide it by 4 instead of going through this long process. So let's do that. I just showed you the walkthrough or a workaround for that. So this 2e raised to the power 2x is equal to e4x over 4 plus c. Let's not forget our constant of integration. So now y is 2e2x multiplied by this and also multiplied by this. So it's going to be e4x all over 4 plus 2c e raised to the power 2x. So now you can decide to, this cancels out this, is going to be 1 over 2. And using the reciprocal laws and the subtraction laws of indices, whereby we can further break this down, e4 over x divided by e2 over x. You can, 1 over a is the same thing as a minus 1. 1 over a is a raised to the power minus 1. So this e raised to the power minus 2x, e raised to the power 2x is equal to e raised to the power minus 2x. So this e4x multiplied by e raised to the power minus 2x. So 4x minus 2x is going to be giving us e raised to the power 2x. So now y is going to be equal to 1 over 2. Then we have simplified this. It's going to be e raised to the power 2x plus c, 2c, e raised to the power 2x. So this is the final answer for this question 1. And we are going to be attempting this question 2 secondly.